Hello, this is Rob Hirschfeld with a Digital Rebar and RackN video. I am a co-founder of RackN and the Digital Rebar project. And we had a request to show some advanced RackN functionality. And so I'm going to walk you through what that looks like. In this case, this is capabilities that are available for people who create a RackN account. And you'll be able to then access some of the content libraries that we have available for login users. This is everything I'm showing you is available just for login. You don't have to pay anything for it. It's part of the registration benefits. And what we're going to be doing is showing off workflow capabilities for RackN. Just so everything's clear, we have a couple of slides that sort of illustrate how this works. Digital Rebar is the scaffolding. It provides the provisioning infrastructure, the protocols, all that work. RackN provides advanced it's not really orchestration, it's really workflow, templates, scripts, RAID and BIOS configuration, plugins, all sorts of things that extend Digital Rebar from a provisioning infrastructure into actual control workflow. Things like our Terraform integration is a good example of that. So I'll be showing you a couple of those pieces. Digital Rebar itself is designed in a way to have extensible packages. So there are community packages that you can use to replace Cobbler or Foreman. Those are basically very straightforward, template-based, open source operating systems. That'll get you started, and then RackN makes things available that sort of take it to the next level. And of course, you can add your own content. The system's designed for that. We'll do other videos showing how we have this composable read-only provisioning system. That's really important. And then the thing that we're going to show is a automated provisioned staged workflow. So it literally takes us all the way through this process automatically. New server, we boot our RAM boot image called Sledgehammer. That has some post-provisioning steps, and then that moves us all the way through into an installed deployed image, and then we could actually reset it and go back. And then one of the things that's interesting that we'll show is some integrations we've done with Packet.net. We do a lot of our demos in Packet.net. It's a really fast, easy way for people to play without having to sort of fight VirtualBox or boot physical machines. So we're very excited about some of these demos that leverage Packet. So I've already installed the system. We have other videos that you can check out that do that. What I haven't done is I haven't actually downloaded any content. So it's pretty much a base installed system. I have put CentOS and Sledgehammer in it, and I have logged in to the system. So there's a very simple login process. You can create an account, and then it will activate this additional content for you. The content comes from the RackN library. It's an online library. Digital Rebar is a behind the firewall infrastructure. So we do not tether, we do not tie, we are not connected to your management. You can run it completely in what we would call an air-gapped situation. You own control. We're making library packages available, and then we provide support for those packages. So in this case, what I want to do is I want to take the OS discovery. So this is our operating system discovery pieces. This handles Sledgehammer, custom discovery, some key injection, things like that. I'm also going to want to add Linux because I'm going to boot CentOS, so I want to pull that over. One of the things about these content packs is they're versioned. So if new packages are introduced, you're going to see a new version number that'll come in, and then it'll give you the option to do an upgrade for those things as you go. And I also want the packet content. So with the packet content, I'm going to get a couple of extra pieces that I'll show off for you. We also have a plugin in the system for Packet that allows us to then do Packet out-of-band management control pieces. So I could actually add my Packet API key and then have power on, power off capabilities just like the IPMI plugin would offer, or we have one for VirtualBox also. Those are out of scope for this demo. I'm just focused on workflow for right now. So here, now that I've got this content, the RackN content adds in stage capabilities. So I don't just have bootems, I actually have a concept called stages. So in this case, I'm not doing the community discovery, I'm doing the RackN discovery piece. I want to use Sledgehammer. So this is the RackN Sledgehammer, and I want my default stage to be Discover. So the stage, I'll describe in a second. Stages are basically this idea of you can have a similar environment, but we're going to move you through different process stages. And each one of those process stages can advance a series of jobs and tasks. I'll show you what those look like in a moment too. So in this case, I've built these stages, and that looks great. So I have a list of stages here. You'll notice we have some icons for in process versus complete. And I'll show you how to build a workflow. The stages, inside of these stages, they have a series of tasks. So in Packet Discover, I have 3 different tasks. If I go into those tasks, you'll see that they actually have a template. That template does the actual work. So the system is designed to be composable. So I've literally drilled down through to see the work of script. So this is just a bash script that goes to Packet's API internally and then sets SSH key, discovers the UUID. So that would be necessary to control. I'll show you how that actually is reflected in the system. But the system is designed in this composable way so that you can reuse jobs or you can reuse templates, and because these are read-only, they are things that are part of that RackN component. You could clone this and then make customizations and changes to it, but if you take patches from us, we know that you haven't modified that source. So if you work carefully and keep using the reusable read-only components, then you're going to be able to stay in with community or RackN pieces. Or if you have a big infrastructure, this allows you to have a master system where you do your development work in CI/CD and then deploy only read-only images out to all of your infrastructure. So you could have 10 or 1,000 edge data centers, and in those cases you would have each one with very careful control and repeatable infrastructure. It's pretty cool stuff. But I'm off topic. So what I wanted to do now is demonstrate workflows. So in workflow, I can have different profiles. So if I added a new profile, I could have assign that profile to nodes and then have them have different workflows. In this case, I'm just going to do a global workflow because I wanted to apply to everything. So let me create a workflow. Remember, our first stage is Discover, so I'm going to start with Discover. And then I'm going to move from Discover to Packet Discover because we're in Packet, so I want to do some work there. And I'm going to say Success. So this is going to automatically move me through these 2 stages. From Packet Discover, I want to go ahead and immediately install CentOS, which I'm going to do, and then reboot. So I'm literally building up the workflow of steps that need to happen during my provisioning process. If I wanted to add in burn-in steps, or I wanted to add additional agent installs, or maybe an inventory or ticketing, all those things could be additional stages in that process. From CentOS 7 install, I'm going to go into a Packet SSH keys because I want my SSH keys installed. Be successful there. And then from Packet SSH keys, I'm done. I'm going to tell it complete, but don't wait. So we have 2 concepts. This exits the whole system, and I can't take additional actions without restarting it. If I went to just complete, we could actually continue to change the system because the Rebar client is continually checking to see if there's new work to be done. In this case, I'm done, so I'm just going to say no wait. Success, save that, and that's the end of my workflow. So now I've built a workflow. Let's exercise it. To do that, I need to know the machine's IP address. It's always useful to have. And I'm going to create a couple more Packet servers in this deployment. Let's see, I'm at Gartner, so and it's Monday. That's the naming of my server. Let's create a new server. We're going to call it test 0. You'll see why. I'm going to do a type 0 here. We're going to pick custom iPXE for the OS, HTTP, not HTTPS, because I'm just doing default iPXE on port 8091. These are all configurable settings, but these are the defaults, so I'm going to run with that. I built this in New Jersey, so I'm going to stay in New Jersey, so I'm not dragging images across the data center. And I must persist the iPXE setting. So there we go. And I want 2 of these. Let's see. Second one of those. Good. Test 1, test 2. I'll deploy that. And then I'm going to add another server, type 1 this time. Maybe I shouldn't have called that test 1. We'll check back on those servers in just a second. Let's see. So I'm going to call this my type 1 server. I'm going to make it a type 1. Boots a little faster. Custom iPXE. Let's see if I can type fast enough. HTTP 8091 default iPXE. New Jersey. And we've demonstrated some actual Terraform scripts that build all this stuff. If I jump back into my deployment, I want to get back to my server list over here. Got a couple of servers. There's my list. What I'm trying to do is grab the console so you can watch the system boot from Sledgehammer automatically into the next system. I think I'll be fast enough. Let's see. Still being built. So if I scroll over here, here's my server GUID. We do this in a couple of videos. It's pretty straightforward to do. Let's see. Yep, I set it up. So this is just the GUID and the packet back-end screen. Good, I caught it. So it's now actually going through our Pixie boot stage, and I can watch it install. So over here, it's literally going through iPXE. It's going to catch the DHCP and start doing a Sledgehammer install. I'm going to slide this over to the side and come back to the UX. So in the UX, what I want to do is jump over to the overview page. And in the overview page, I get live updates of stages. It's using the same WebSocket interfaces that we have here. It's got a socket that subscribes to the stages for machines. So as this system comes up, and we're waiting for it to boot Sledgehammer, what we'll end up seeing in here is systems already coming through. What we're going to see is systems that we've installed, and they're going to go through the inventory infrastructure. So you can see up here, I'm updating it. Systems automatically driving through different stages. So both of my systems, looks like one of those systems. This one, no, it's coming up. It's just a little bit slower than the other ones. And so it's showing up through. You'll notice how fast it went through Sledgehammer, did some post-provisioning, and it was done and moved all the way into CentOS deployment. Let's see, that next machine is going to come in just a little bit. We can watch it down here. And it's booting in the background. Let me see if I can make a little bit of space on this. So this is the Sledgehammer install going through. We'll get into a point where the Sledgehammer's up. It's going to automatically do the extra steps to get the packet key and then move it directly into Sledgehammer install. So since all of this is driven with the client pulling jobs down from Digital Rebar, then there is no lag time. We don't need SSH access. We don't need any additional steps. I'm actually already through. We went straight from the Sledgehammer booting, did the little bit of work, and now it started the installer for CentOS. It was that fast. Right, because we're not waiting to register into a central system and a client with that. We're just using Digital Rebar's CLI on the system to pull down jobs. So a couple more things I want to show you in this. So here we have our 3 machines. They're all in cent install. That type 1 is going to finish a little bit faster because it's just a faster machine. And if I went to one of these machines, what you'll see is that packet SSH registered the packet in a the packet server. And if I had installed the plugin, it's another video to show you for how to install plugins and manage them, I would have power buttons. for this. So the system's just going through, doing its thing. And part of the task system creates jobs. So every time a task is run on a system, you're going to get a full logging infrastructure. It actually records the file and the output from that task and then stores it back in. We haven't written the UX. It's on our short list of features to add to the UX, where I would actually pull back the log so you can see the log. By the time you're watching this video, it might already be in. But these are logs that are generated from each one of those activities in the system, and I can get real live quick updates about what's going on exactly in my system, where the status is, and if we wait just a little bit, the CentOS system is going to come in and be installed. At least the type 1 is, because it's a little bit faster. And like I said, it's live updates in this case, so as soon as that changes, we'll see the new stage report in, and it's literally going to be too fast to catch the intermediate stages of the packet install. Let's see. So while we wait for this, I'll explain something that's really important to us and the way this works. This is it's not exactly an agent system, and it's not exactly a pull system. The Digital Rebar Provision infrastructure allows us to have a stage. The stage has tasks on it, and in that stage, the node uses the Digital Rebar CLI. It's a feature of the CLI to pull in those tasks and execute them, and sends the resulting job completion back up to the server, and then advances to the next task. It's very simple workflow, but very effective. So from that CLI, we can take actions on the server. We can take out-of-band management actions via the server. The CLI only can act on that one node, so it has permission within the system and our token auth system to take actions only on itself. So you could do something within the context of the machine, like reboot and reimage the machine. That's totally legitimate, and that allows us to create these very effective workflow systems. It's what drives the Terraform automation, which is pool-like behavior. I suggest you look at that video. Several other videos show this same capability. I wanted to highlight exactly how you build a workflow for this. It's very simple, and yet really powerful, because if you add stages or want to extend a stage, you wanted to add your own stage into the system, you can totally do that. So you can take a stage, you can add here, and create, say, a burn-in stage, and then just add it into the workflow as a process piece. And so that's entirely feasible to do it. You'll notice some of these have checks and X's. The check means that that stage is usable. It's the ones that aren't usable are not usable because they're missing the ISOs. So if I look at this stage, it'll actually tell us that this stage wants a boot environment Cent7 down here, which is not available. So you can see the jobs are running now. So let's check back in on our overview. So in this case, 1/3 of my environment is ready. It's complete, no wait. So I was able to see that in these actions. We actually have a Slack plugin that takes these same events and sends them to Slack, so you can see them in your Slack channels. The two type 2s are slower, so they haven't completed yet, which is exactly what I was hoping to show you. As soon as they complete, we will see the system live update into all three into ready state, and the system will finish with that. I don't think it's in screen, but you can see it going through the install process. Type 2s are a little bit beefier, so they install quicker. I hope that answers your questions about how Digital Rebar workflows function. If you have questions, please. Some of these advanced features, we are behind on the documentation. We're happy to talk in community. We have bi-weekly community meetings. We're planning demos and things like that. This is really exciting functionality. We would love to talk to you about it. Please feel free to jump in the community and be part of the dialogue on how to make operations fast, repeatable, and just plain awesome. Thank you.